Maybe as an easy way to start, tell me a bit about your background.
Sure thing. So I have a degree in mechanical engineering from University of Texas at Austin. And upon graduation, there are a number of different venues open to, and this is in the late 80s. Majority of the venues open at the time were um, oil and gas industry, electronics, less so automotive and defense. And I had at that time been really using the Apple Macintosh and had become really fond of it. And I wanted to use my mechanical engineering education to go down that route. I didn't end up, although I applied for Apple at the time, but later on, much later on, I ended up working for them. I started working for semiconductor manufacturing for IBM back when IBM had a mainframe business making mainframes. So I was doing that for a few years. Then I was with Motorola Semiconductors, where their automotive division, they're at the time, now after many splits and dissolving, they are referred to as On Semiconductor or On Semi, if I'm correct. After that, I was with a couple of small startups, but then I joined Dell, where I was at Dell for 11 years, the majority of it as a new product introduction for the portables group. And then after that, I was a supplier quality engineer and then a supplier quality engineering manager. And the area that fell under my supervision was desktop motherboards, and then graphics cards, the electronics that went on it, and the chassis. Essentially, the entire desktop product fell under and the supplier management of that fell under my team's responsibility. Then after almost 11 years at Dell, I joined Apple. With Apple, I led also a supplier quality engineering team, but later also expanded to general overall procurement of mechanical enclosures for Mac and portables. And I also wore global quality leadership role for Apple audio products, the Apple Watch, and the iPad. Yeah. So, and then since then, I've been had some leadership roles in a number of different startups. But what's really relevant to this conversation, I believe, is predominantly my experience at Dell as a supplier quality lead for motherboards for desktop and occasionally server applications.
So you've been around a bit. You've worked for a few small companies.
That's right. That's right. That's right.
You didn't just dye your hair gray.
No, 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 I did not.
It looks great on you. So
Thank you.
it's you never know.
Thank you much. I appreciate that.
No, I mean, I think one of my favorite Apple stories is how before kind of Steve Jobs' obsession about customer like user experience, people used to ship your laptop, your desktop, and or your laptop, and you had to charge the battery. Right, so he was very passionate about, we need to find a way to send them batteries that are charged. So, like to me, quality is not just about quality; it's about the user experience, like when the customer receives it, right? So I think that the things that you have done in your career, regular folks can relate to, because there's nothing more frustrating than opening the box of something new, some electronic thing, and it not working like you wanted it to work, right?
That's right. That's right.
So
And
what I mean, tell us a little bit more about your experience specifically in quality, and like what is that like? What is a day to day? What are some of the joys and frustrations?
um, sure. So, how I got into quality was a bit of a round. I was a manufacturing slash process engineer. At some point, as Dell's production and the suppliers that furnished those motherboards started moving overseas, my job metamorphosed, if you will, from a process engineer, equipment engineer, manufacturing engineer to a supplier quality engineer. And what that means is working with the suppliers to ensure that the products that they ship to uh, our assembly facilities, FATP as they're called in the electronics world, final assembly, test, and pack out, the products that they send to us do not need any type of incoming quality uh, inspection, that they go straight from the box into the chassis of a desktop, if you will. And working with them, reducing their defective parts per million in a surface mount technology line, in a reflow line. It was essentially working with your suppliers to make sure that they're not just catching defects at the end of their line. By then, it's really too late. It's too expensive, but really working with them to improve their manufacturing process so that A, they're more profitable. And as they improve their manufacturing process, the product that gets to the end of the line is also going to be a more robust and reliable product over long term. So it's supplier development, working with them to, lead-free initiative, for example, or as they expand and set up. Take an example, and I'm just thinking out loud, thinking off the back of my mind. Let's take a contract manufacturer like Selectron. Uh, they would come to us. They say, we have a facility in Penang, Malaysia. Would you be interested in exploring that? We think we can scale better with a more interesting cost structure. And we would say yes. So that would require people from my team overseeing that transition, that transfer of manufacturing from one facility, one geography, one continent to another.
It's interesting. So, what's something you said about scale better? I want to dig into that a bit. What does it mean to scale better? I mean, you followed that with cost, but is it all just about cost? What are people looking for when they want to scale better?
That's a very good question. That is not. I think many people think that that is the case. Scaling better requires not just a more attractive cost structure, but also the individuals available and the talent that is required to make these things. And for the past 25, 30 years, that has been China. Having these individuals that have the right level of training, education, ambition, and mindset, and having enough of them to be able to assemble electronics, consumer products for the whole world. And that's not just Apple, it's Dell, it's HP, it's Lenovo, many, many different companies, and their sub-tier suppliers that feed into that. So that's what scale means. Also having the infrastructure, the roads, reliable electricity, reliable wattage, access to water, access to food supply for all these somewhat migrant workers. So all of these are really critical things that need to be considered when we talk about scaling.
So when you say that, I'm thinking that, it's not just about cost. Like you said, it's really about like possibility. Because if you don't have these, like what you're managing against is, can you actually get anything done?
Correct. That's right. That's
and
right.
then if you can get something done, will you be disrupted? So speed matters then, like delays. I mean, were there a lot of delays in this industry where people would try to get projects going and then products slip, they get delayed? What's the cost of that? I guess.
The cost of that is extremely high. That's why you work with contract manufacturers that, uh, without mentioning names, uh, many of them are uh, Taiwanese companies with large footprint in China. These companies, they know how to scale. They've done it before. Uh, when Apple is growing, or when a company, and I don't want to mention Apple, when a company is growing in a very rapid fashion, these companies provide solutions. Okay, on the Chinese seaboard, Eastern seaboard, we don't have that much access to new labor force. The costs of operation have grown very high. Would you, company A, B, or C, be interested in moving inland? Okay,
Mm-hmm.
what are we talking about? Chengdu, Sichuan province. Interesting. What is your plan for that? Here's the work stream. These are the buildings that are going to be built within the next 6 months. We're going to put factory floors. This is in about a year, you're going to have X volume that you can build in central China. That type of agility is really not available, has not been available anywhere else. So,
Yeah.
um,
No,
uh,
and that's important. I mean, I think just sorry to interrupt, but I mean, what you're
no, no, no.
saying, to me, like when you're offered that and you get it, the last thing you want is for it to be delayed further because
Correct.
you're buying speed, you're buying accessibility, you're buying speed. So that takes me to like when we were first discussing and we first met. There was an article that I think I shared and we talked about from 1999
Yeah,
about heat sink attachment and thermal interface effects on production,
that's
assembly, and repair.
that's right.
And we both kind of looked at like, wow, like this is still
Valid.
relevant
That's right.
today because these issues still exist today, right?
That's right.
But back in 1999, there were no $30,000 chips, right? The reality is the electronics have gotten more expensive, more important, more geopolitically important for countries and societies, right? Yet you still have this issue where the heat sink attachment and production, assembly, and repair are important. And I think the more, one of the takeaways I got from that article was that the more expensive the product, the more you need to rework it, the more you need it to be serviceable. But what's your view on these issues and these challenges that sometimes are overlooked?
That's right. Any new product, any new product has electronics in it. The electronics, well, there's physical reliability test, drop test, um, um, vibration test, but then there is also a burn-in test. What does that mean? You take the motherboard or the specific PCBA card and run the electronics and the test through it hundreds and hundreds of times. These boards will never be reused. They're essentially sacrificial boards so that you learn how these boards, how this electronics operates, gaming situation, highly demanding graphics simulations. All of these are running on rows and rows of racks in somewhere in these factories. As these are running and the leadership at, say, a computer company, without mentioning a name, just let's say Lenovo or HP or Dell, the leadership says, we have run through 90%, we're supposed to run for a week straight of simulation. as an example, we've run through 80% of it. What you were just talking about earlier, which is speed, we are pretty confident that everything is fine. Let's do risk ramp, which means start building at volume. Fingers crossed, this last 20% is not going to give us any major heartburn defect-wise. Most of the time that works. Most of the time that is fine. There are occasional times that as this suite of reliability tests are done, you find that a certain specific chipset has a corner case issue that is found after X number of iterations and tests. Now, what do you do with that first 10, 15, 20, 30,000 motherboards that you've already built and is making its way to the channels? You can either fix on fail, customer comes, you give them a new board or a new computer, or you can proactively go and rework everything. So in my case, when I was a supplier quality engineer, I was responsible for doing that for a certain Intel chipset. Now, this is 15, 20 years ago. I don't recall the specifics of it, but this one particular chipset had an issue that needed to be reworked. And every single BGA, if I remember correctly, had to be removed and replaced with a fresh batch with corrected silicon. So this was obviously stressful and fraught with opportunities for error. So that's a clear case example of what are some of the things that you can come across.
Well, I think I remember, that was a good example. I think I remember you telling me that your favorite part of that process was thermal paste.
It was not. I like how you said it with an absolute straight face. Yes. No, it was not. Because, first of all, very gingerly, and there's equipment that is used to provide local heat. First of all, you have to remove the cooling module, the heat sink, and then it's got all kinds of paste underneath. You have to clean the paste. Then you have to remove the paste from the top of the chip. And you can imagine anyone who has removed caulk from their bathroom or tape or it's really dirty. It's not efficient. And the most important part of it, not repeatable, because you're relying on different people with different, amount of care to do this. I have two kids. Part of their job is after they brush their teeth to clean the sink of any residue toothpaste. From night to night, son to daughter, it's taken me a year to get them to actually perform at the same level, regardless of whether it's in the morning or in the evening. So there's
you sound like someone who has experience with thermal paste that you even specified that to your children.
Yes. And toothpaste, dried toothpaste looks like thermal paste, Bara.
That's right.
That's
I'm gonna steal that one for you. I'm going home tonight and I'm gonna tell my kids,
That's right. It's personal.
It's personal. I don't want to see any of it.
That's right. So I actually never thought of it before. What my sense, and my wife sometimes like, why are you so sensitive about this? And I guess maybe it's got some PTSD.
You got scar tissue. Yeah. you see toothpaste, you're like, I can't resolder.
I can't resolder. I can't. That's right. I have to chuck that expensive CPU or chipset. So that is the long and short of
Yeah.
it. And when you and I started, having a conversation, and I understand your product and how it works, it was such an aha moment for me. It was such a moment of this. Why isn't anyone and everyone running to this solution? Um, you know, with wild abandon. So
Yeah. Yeah. Well,
I personally,
I want to get to the Carbice solution before we do. You know, like these issues. You mentioned something breaking, having to take it out. I mean, there are different levels of complexities in electronics, right? And in many ways, they're getting more complex, right?
yes.
So this percentage of things where you need to rework and service, do you think how does that interplay with increasing complexity?
So to be honest with you, I personally have not been elbow deep in it for a
Mm-hmm.
number of years, but I can imagine that as um, the demands on computation power increases, as the cost of chips and chipsets and GPUs and CPUs increases, that there's going to be additional opportunities for corner case errors that will need to be repaired.
Yeah.
Um, there are Swiss companies that make a fortune making really localized repair setups that can isolate because you don't want anything else around the part that you're removing. In an ideal world, you can fix that with firmware.
Yeah.
You don't have to remove anything. But if you have to remove it, you want to isolate all the components around there so that there's no reflow event except for the part that you want to remove.
Yeah.
So uh, and then when you replace it and you want to attach the cooling module again with the appropriate interface, ideally the Carbice interface, that is at this point being done manually. It's no longer being done in an automated pick and place machine.
Yeah. Yeah.
Someone is doing it because you can't put that board again through the chip shooter or through the pick and place machine to attach this heat sink. Someone needs to lower it as perpendicular as possible to the top surface of the chipset that has been replaced to make sure that there's no gaps, etc. And with thermal paste, you will have bubbles of air, or you're going, and what that does, and as a quality engineer, I was also privy to these boards are a bit like walking wounded. Sometimes they last so many months, years, cycles, but then they fail. Their failure rate is higher. So
Yeah.
you
Yeah.
you really want to avoid that part of it too. So there's
Who pays for
multiple
that? Who pays for that failure?
the companies. The contract manufacturer doesn't pay for it. From my understanding, it's the OEM, the direct to consumer vendors such as Dell, HP,
Yeah.
Sony, uh, whoever that company is, Asus Tech, because they have to go, and if it's under warranty, they have to replace it. Um, and once things pass, so first, second, third level failure analysis of these boards is very expensive. So a lot, in an ideal world, I would know as a product quality engineer, I would love to know what percentages these parts that are come back as defects were parts that had been reworked.
Yeah.
15, 20 years ago, the data stream was not as rich as it is today, but I'm sure that should be available to a good quality engineering manager. This person should know what are the ramifications of this type of rework on field quality, if not
No,
immediate, but over time.
it's interesting. I'm not sure I mentioned this to you, but we've been looking into and speaking to a lot of contract manufacturers, and we find that in some parts of the world, they only have one person in the whole factory that can do re-stenciling and paste. It's such a complex process, right? And people have rework rates as high as 10%. And as you mentioned, they don't worry so much about it because they don't take the cost. They pass the cost. And I think that, so getting to, Carbice, we are very intentional about trying to communicate our value to the market. It's a high performance interface solution. And we say really it stands alone because it's the only high performance thermal interface solution made for scaled operations. And I think that last part about scaled operations, you're really helping to shed some light on, because people don't think about this fact that when you rework, you can't go back to automated assembly, that you can't get away from hand assembly. And even a lot of times we find that first assembly still is hand assembly.
Yes.
So what are, from your perspective, what excites you about the Carbice approach and why it's different from traditional thermal interface materials?
First of all, it takes the guesswork out of how much paste should I put on. The less the operator has to decide, the more repeatable your process is. I always, whenever I walked in walked the factory floor, etc., I would ask the lead process engineer, "Are you paying this operator engineering salaries?" And they would look at me like, "What are you talking about?" And I would say, "Because you're asking them to make decisions that you should be deciding and write it in the SOP, standard operating procedure. This is lazy engineering. You need to write down what this individual needs to do so that they don't have to come to a crossroads and decide, oh, should I do this or should I do that?" Paste, by its nature, requires someone to just sit there and go, did I put enough or did I not put enough? With your solution, it's just a cutout the size of the chip, and you just remove the adhesive and put it on there. Just right off the bat, it's so much more repeatable. Even if you don't, fully understand the thermal ramifications, the thermal benefits of your solution, it's just off the bat so much more repeatable. You don't have stencils to clean. You don't have tools to clean. Let's say a chipset that is incorporating your product needs to be replaced. It's so much easier to remove. At the minimum, you can save the cooling solution, the cooling module. You remove the chipset. It's just cleaner, more repeatable. It's a better thermal conductivity. To me, it's just a really clear case of a superior solution.
It's like a toothbrush that brushes the teeth without toothpaste.
That's right.
So your kids don't have anything to clean up.
I don't know.
They get like 15 minutes back for video games.
I got to think about that. You brought up, they have 30 minutes of video, they call it screen time. I call it video game, and they call me old fashioned for calling it that. screen time. And then on the weekend, if I see any specks of toothpaste in the sink, it's 10 minutes removed for the following session. So
It's a high price they pay.
there's no emotions. It's just no one gets angry.
So we're on a mission to get rid of thermal paste and to figure out how to make toothpaste better to clean up. I guess
I guess
for
so.
your kids' sake.
I think they just need to. I, I think they just need to be less rushed.
I hear you. I hear you.
Yeah,
So I mean, I want to be respectful of time. I mean, as we get near the end of our window,
yeah.
like if you could change anything about electronics assembly and manufacturing, what would it be? You got a magic wand. You say, "What? How do I make this easier, better for people, for customers?"
So this would be. I mean, there's many areas that I can think of where there's opportunities for improvement. The fact that bare boards need to be vacuum packed and stored in special thermal cooling environments before use to prevent there's many areas, but this one specific area, given the solution that you all have, I don't want to sound condescending, but it's like a no-brainer. It's such a clear case of an opportunity um, to do away with what's essentially an imperfect solution,
Yeah.
which forget about the application and the cleaning and all of that. The fact, because of its natural inconsistencies in the paste, you're going to have heat spots. And that's going to reduce the lifetime, the long-term reliability of any given chipset, especially the temperatures they're running at nowadays. So this is a good one to tackle. This is a relatively easy one to, and from a cost perspective, you and I had a discussion about total cost of ownership. That's also, I think, a clear case of using this opportunity, this solution, rather than thermal paste.
So I mean, just building on that to conclude, like, so I mean, no brainer. You're not the only one that says that. I think we hear people increasingly when they can really appreciate, like you, the full picture. They're like, why would you do the other way?
Yes.
But I mean, for engineers dealing with this issue, new, old, and ones unfamiliar with new technology, what advice would you give them? How should they go about, I guess, because engineers work within their organization and
Right.
they have a lot of different people that they interact with. What advice would you give them to help make real progress in this space?
Design engineers, and I don't like to generalize because it gets one in trouble, but design engineers are by nature conservative individuals, and already they're innovating at a insane speed. And if there's certain things within this innovation bubble of this innovation, if there's certain variables they can keep constant, they will focus on other things that will really drive speed, availability, so on and so forth. So they may be convinced that, yes, this is the right solution, but no organization is going to accept your word or mine. They're going to need to qualify this solution. And that can take enormous amount of engineer hours and cost. So you ask me, this is such a fundamental change that this may need to be a leadership, high level leadership solution proposal that then the individual design engineers say, gosh, I guess I need to go work on this.
Yeah, yeah.
That's my hunch. I may be wrong, but I think because
Well, because it's a culture change. What you're saying is
it's a
it's a
complete
culture
culture
change.
change.
It's almost like when before everybody's used to OSATs and other people making their chips, but that wasn't how it was, and it became a culture change, right?
That's right.
And maybe this. You go ahead.
No, go ahead.
Well, I said, yeah. I mean, that's what it sounds like. I mean, I think those things do have to happen at the decision maker level in the
That's
business.
right.
Yeah,
That's right. And a few things drive this type of change, mentality and culture. And one of them is profitability, technology, and technical superiority over competition. And some of them are forced by global governmental environmental agencies.
yeah,
The lead-free initiative was very costly. No one obviously wanted to grapple with that at that time, but they put a deadline and say everyone needs to be lead-free by this date. So everyone started, okay, this is not the case here, although one would argue that thermal paste is can be pretty nasty. But this is something, there needs to be some type of driver and that motivates senior leadership to invest time, resources, and capital. So that's perhaps part of this conversation you and I are having,
yeah.
to make this case that you need to do this to get to the next level, of performance, and performance being an umbrella word for quality, reliability, long-term reliability, immediate performance, etc.
Well, I think, Zod, you nicely through this conversation framed the consequences of really being left behind.
Yes.
I think things move fast, and what we see, the world, anyone in electronics, is that to move slow is to be left behind.
Yep.
And I want to thank you for having this conversation with me today. I'm always energized after speaking with you. It's always have a few good laughs, and I always walk away with a few good new insights and nuggets as well. So thank you.
You're very welcome. My pleasure.